I really am incredibly excited to be here today to talk about probably my favorite topic in the world to discuss, and that is just the web as a whole. You see, I've been a fan since I was really, really little. I lived in an area that was lucky enough to be involved really early on, and so I got exposed at a young age, and I've been obsessed with everything about it from a very early time. Um, I think the thing that I always found the most interesting is sort of those early days when the web was new, when it was kind of small and simple. And the thing that fascinated me about that was always the fact that that smallness, that simplicity, kind of allowed it to be fast in a certain way. Not really in a relative sense, I guess is what I'm saying, because well, when your websites look like this, it's hard to make them slow. Like at least as a web author, there's not much you can do with a couple dozen ASCII characters to make it slow down. And I always thought that was fascinating. You know, at the early days, that anyone, no matter who they were or what background they have, if they've been making software for 30 years or 30 seconds, they could just save a file. It was pretty much as good as any other website. And I found that really, really amazing, like how approachable that could be. Imagine if C was so approachable that you could just start writing code and it worked and everything was great. It was just as good as anyone else. It was fascinating, you know, but and the reason for all of that, I guess, was because, you know, there's not much you can do to mess up ASCII characters. You know, there's nothing there. And of course, the flip side of that is the unfortunate, there's not much you can do, period. I mean, text doesn't really do that much. And so over time, we needed to add a lot more features to the web in order to actually make it useful. And so really pretty rapidly after the web started evolving, we started getting stuff like images. This is some of the first images that were ever online, actually. It's some of the Tim Berners-Lee's coworkers from CERN. They were made one of the first banned websites and the very first images on the web, just months after the first web browser was launched. Shortly after that, we had How Come Lee publicly proposed CSS on a mailing list. You know, we started to see the seeds of things to come. You know, like the web that we have today started to actually form more than just simple text. And of course, a little bit after that, we have Netscape and Sun announcing JavaScript, you know, having that whole Brendan Eich over the weekend developing how most of our jobs are created nowadays. It's really amazing how quickly we went from just that incredibly simple concepts to, you know, basically what we have today. You know, over just a couple of years, we got everything almost all at once. And of course, it's evolved and gotten more complex. But it wasn't until that point where we started to have all of these additional features. It was no longer just that one file you could write, that this concept of a web developer started to come out. This idea that you could actually you know, as a job, you had to memorize all these things. You know, you had to know all of the nuances, all the new APIs, all the new concepts in order to actually do something. It's a stark contrast from where we started, but it was really, really, you know, necessary in a lot of ways. You have to become slowly an expert, and obviously that just accelerates over time. And I always was kind of bummed that, you know, it's almost a tragedy. You shouldn't have to be an expert to make a website, right? You shouldn't have to know how to make a website about anything you want. You should just worry about what you want to communicate, not how you have to do it. And that's one of the reasons why I was drawn to the AMP team originally, you know, having that ability to take away all of the unnecessary decision-making that comes with modern web development. You know, if you want to, that's great, you can do it. But if you don't want to, if you want to just have stuff that functions, you don't have to think about stuff, you just can make the content you want, then AMP is a fantastic option for that. And you know, that idea of removing the noise, you know, having stuff so that's just focusing on things that are actually important is something that I think is important to a lot of the team, and is one of the main reasons why I think we were so excited when we had the idea, when the AMP team came out with the announcement of being in support of Core Web Vitals. Web Vitals in general, if you're unaware, is a new initiative from Google. It came out just a few weeks ago. And the idea is sort of to simplify and solidify the language that we're using when we're talking about web performance. You know, it's a really nebulous idea. You ask 50 people what web performance really means, and you'll probably get 200 answers. It's hard to really understand that in a modern context. There's way too many APIs, way too many intersections. And so Web Vitals helps us simplify, you know, focus down on what things actually matter. It's really a measurement of anonymous user data coming from real users actually using your website. It's not like arbitrary lab data or something like that. And that's one of the reasons why I'm so one of many reasons why I'm so excited about it. I unfortunately was not given an entire day to talk about Web Vitals, and so I would need to show you web.dev/vitals if you'd like to learn all about them, because there is way too much to fit into a single talk. However, in this talk, I would love to talk about how AMP is addressing just a small portion of Web Vitals, but honestly, the most important ones, the core Web Vitals. So again, sorry, that was web.dev/vitals to learn more about Vitals and Web Vitals in general. It's a great primer as a background, but the stuff we're going to be talking about today, I'll try and cover in here. Specifically, like I said, core Web Vitals comes down to three-letter acronyms. It's LCP, FID, and CLS. Individually, they all make up different major aspects of what I think we believe they're just fundamental to good user experience. You know, this is true for all websites. You need to make sure that you are not only measuring this, but optimizing these things. Those letters end up standing for LCP, or largest contentful paint. This is all about how fast your web pages feel like they're loading. So this is, rather than traditional loading metrics where we look at like network status events, LCP actually measures when a user sees the pixels being painted on the largest content inside of the page. Things like images, videos, things that are likely to take up a large amount of space. Chrome will automatically check for when that occurs, and then it'll keep track of that. And you want to make sure that it happens within a certain amount of time. That 2.5 to 4.0 seconds is the goal for most websites. After LCP, we have CLS, or cumulative layout shift. This is a bit more complex to actually explain. It's usually better to show, and of course that video isn't working. Hold on, I am not giving up that easily. We have a, so cumulative layout shift is all about sort of understanding how stable a web page is. It's pretty easy to see how frustrating it can be if you try to go to use a website and it is jumping all over the place. You know, you have all kinds of banners, pop-ups, things that would normally be, normally just prevent you from actually interacting with the page the way that you want it to. Apologies, I am resharing. No, I'm not sharing a screen, I apologize. I'm trying to bring up a separate image. Then I'm gonna give up now. Apologies, everybody. I will try and show that later. For some reason, my slides are being horrible today. Yes, so the idea there, let me jump back into presentation mode, is going to be that, so you know when you're interacting with a page and you try to tap on a button or an input, and then all of a sudden you have a pop-up banner, maybe a cookie notification or some kind of banner sales to try and get you to sign up for email, and you tap on the wrong thing. It's a horrible user experience. It's something that everyone hates. And as a result, you know, we're trying to make sure it doesn't occur. Sorry, I need to bring up my slides now. We need to make sure it does not occur. Now, let's see, where are we? Nope. Just want to make sure y'all are seeing my slides now, correct?
Yes.
Great, thank you so much, Joy. Again, thank you for all the patience, everybody. Outside of so again, CLS is all about CLS is all about web page stability, making sure it's not jumping around in a way that's unexpected or irritating to a user. Finally, we're going to talk about FID, which is first input delay. This is something that actually really interested me. It was the one that stuck out the most when I first started hearing about core Web Vitals. And the reason is I think it's a fairly unique metric. It's not something I've seen a lot of people actually measure in practice. What makes it kind of unique is that first input delay actually measures how long it takes for your web page to become interactive from a user interaction. And so what that means is when you go to tap on a page, if it's like an input button, some kind of interactive element, it's going to check to see how long it takes for your web page to become responsive. Now, in theory, this should be 0 milliseconds. Like things should just work immediately. But anyone that's built a web app and using modern technologies in the past few years, I'm sure you've seen really large JavaScript libraries or server-side rendered code that ends up sending more of like a picture of a website that has to be rewired up before it actually is functional. It's something that is frustrating for a lot of users. They don't understand why the button isn't working, why your menu isn't opening, or your input isn't actually bringing up a keyboard. And it's something that FID, optimizing for, can make sure that you are avoiding that annoyance. And the great thing that I was really relieved when I started investigating a lot of this stuff is that if you stick to AMP's best practices, you use a lot of the tools that we provide, you are actually set up wonderfully to deal with almost all of these things. I'm fairly new to the AMP team. I've been there for less than a year, and I had a whole bunch of learning to do when this came out. I was really interested to see how we were addressing these things. And so I wanted to take this time to share some of the stuff that I picked up, sort of like performance secrets inside of the AMP library, and share them with you. So the first thing we're going to dive into is how AMP is dealing with the first input delay. So again, first input delay is all about making sure that a website is becoming responsive quickly. Usually, almost all FID related issues comes down to the fact that the browser by default is single threaded. It means it can only interact with one thing at a time. So if you have you're loading images and in the middle of that, you try and put a script tag or something that's really large, takes up a lot of processing time, you're going to stop all those images from being loaded below it. It can mean that the page is no longer interactive while you're trying to touch it or do stuff while that JavaScript code is being interacted with on your especially lower end phones. And as a result, we try to avoid that or optimize things to make it so that we can use the browser's alternatives to single-threaded mode whenever possible. That brings me to the first point that I want to talk about here, which is AMP always attempts to use any kind of asynchronous API. Now, this is really important because back in the old days, the early days of the web that I hearkened to earlier, a lot of APIs were added because they needed to be there. But most of the time, they were focused more on developer experience than actually performance. I mean, just the fact that it worked was performant enough for most people. And so we have some bad things that still exist on the web platform for backcompat. Examples of this would probably be stuff like document.cookie. That's something that has to synchronously theoretically read from a disk, which could be incredibly slow, all kinds of stuff. And so we want to avoid those types of synchronous APIs and look at the more asynchronous versions. Another call out of something that we would absolutely never use inside of AMP is something like a synchronous XHR or synchronous AJAX request. This is something where if you set that final true value, you actually stop processing all code, no matter what, if it's doing, if you have any kind of JavaScript interactions or listeners, they stop until that JavaScript network call comes back. Obviously, it's a horrible idea. You should never do it. It's attempting to be removed from browsers. We just have to update several million web pages before that can be possible. But AMP tries to avoid all of this. It makes sure to always use modern APIs if they exist. Avoid things like document.cookie, looking towards more asynchronous storage methods, things like IndexedDB or local storage or anything else that kind of avoids that complete stop of the processing stack. We want to always go towards the modern version of those APIs. Outside of that, asynchronous APIs is something that's kind of just generally best practices. And so it's something that hopefully you're doing already in your code. The first thing that I was really interested in or really particularly stood out to me when I was looking through AMP's steps here was how it deals with deferred layout. So AMP's deferred layout is something that's kind of fundamental to how it deals with a lot of stuff. The idea there is that AMP is a collection of web components, effectively, right? It's a bunch of widgets you can use to build a web page. And so because there has the ability to understand where all those widgets are, what they're doing, and a whole bunch of other rules on how they behave, it can do some really interesting things with how they're actually laid out or displayed on the page. For example, in this beautiful website, we have a couple of kittens inside of photos, and it can tell that right now we have two things on the image in the viewport, the thing the user can actually see, and then below the viewport, we have more images. Now, since AMP is aware of all these things, the static layout, where they are, when they're being loaded, et cetera, we can actually defer that image, any kind of component or image or anything else that happens below the fold if we choose to. AMP has that ability internally in that library. By doing so, by deferring that content until a later point in time, it allows us to potentially optimize for anything that might be more intensive that the user will actually see, making sure all the fonts are loaded, all of the all the JavaScript events are wired up. All the things that the user is the most likely to interact with will be prioritized above anything else that's below the fold. It's not necessarily always just below the fold. It can certainly be anywhere on the page. AMP has that ability. The point in general is the fact that AMP has the ability to defer a layout or delay when something is actually going to be loaded to ensure that the thing the user is the most likely to interact with will be interactable in the future. The next thing I'll notice that I thought was particularly interesting are sandboxes. Now, sandboxes are something, oh gosh, another slide failure. I'm sorry, guys. So sandboxes are effectively the idea of just separating code from each other. I mentioned before the idea of the browser by default being single-threaded. And AMP can avoid that problem a lot of the times by having all these really strict rules with how it actually handles code. You know, it has the ability to say, I will only run asynchronous code, or I will never call these, I will never block other API calls, things like that. And unfortunately, AMP can't do everything for every website. You know, sometimes you need third-party code. You might need advertisements, a widget from another library, or social share button, something like that. And as a result, you need to import code from another party, something that AMP didn't write. And since they're not guaranteed to be strict to our guidelines, we have the ability to bring them in inside of an iframe. Iframe is just the standard web browser built-in widget thing, and it allows you to load that content inside of a different rendering context. By loading it in a new rendering context, it's basically a new tab inside of your tab. It allows you to break out of that single thread. It has its own thread that it can do whatever it wants. If it decides to have horrible performance inside of that single thread, it won't attack the surrounding AMP page. So AMP effectively isolates itself from any kind of third-party code that it can't control by pushing it over into these sandbox environments. You know, they can't escape that. They can't escape that sandbox, therefore keeping the performance of your page at a higher level. Now, moving quickly over this, because I know I'm well behind time already, I apologize, is next thing I want to talk about is CLS, or Cumulative Layout Shift. And again, see if that video loads. Nope, it didn't. So CLS, again, is all about looking at the web page's stability, making sure it's not jumping around, hopping over, making it's predictable. You know, when the user tries to tap on something, they're tapping on the thing they actually intend to. That's what we're generally looking for when we're measuring CLS. Now, probably one of the bigger things that AMP does to prevent any of these types of issues, CLS-related issues, is having statically sized layouts. So what that means in practice is that things that have dynamic height or dynamic width, so images, videos, third-party content, stuff like that, you add it into your page, but the browser can't automatically know by default, just by setting a source, how tall or how wide that image is. You know, so it just has to guess, and it's going to guess 0 by default. So in this example, a better version might be, imagine if we had 2 lines of text with an image below each one. Now, if we didn't set a height and a width, where we kind of preserve that height space for that individual image before the network can download them, then the text starts out right next to each other. Then as soon as they come in, it jumps. It's a bad user experience, especially if you scroll down through the page and all of a sudden things are flying all over the place. It's a horrible user experience. And AMP can get around that, or prevent that issue rather, by requiring all images or videos to have a statically set width or height, or both. That means that the browser understands how large those things are going to be before they actually download and parse those images, which allows for a more stable layout system. Separately, another thing was this idea of interaction being required for dynamic content. And so, apologies again. Super fun. Yeah, so the idea here is that in order to dynamically have a pop-up, so a really common experience for people, especially on maybe if you're trying to buy something from a unscrupulous website, let's say, and you go to tap on a button, they might pop up a sign up to our email or move a checkbox right at the last second so that you accidentally tap the wrong thing, you know, one of those dark patterns. AMP prevents that from happening by not allowing websites to inject data where it'll pop up or modify the DOM in some way until after the user has actually created some kind of an interaction. So you can't pop up a thing for somebody to touch before they've actually touched it. It prevents a lot of those jumping experiences that people have on websites with a poor CLS score. It's something that AMP can give you for free if you stick to valid AMP. It's something that I found a really interesting idea. And then, oh goodness, man, I'm so sorry. Okay, so next up, I guess we'll be talking about LCP, which is the largest contentful paint. That again is kind of measuring the loading performance of a web page. So this has to do with when the largest portion or the largest element on a screen, that viewport that we talked about before, has actually begun to be painted. So that's something that can visually make the user feel as though things are loading faster than they might otherwise happen. It's something that's really all about the user's experience. So one of the newer things that AMP is doing around this is this idea of having a blurry image fallback, which might sound confusing, but the idea here is that rather than load the entire image, say those large hero images that are at the top of a page, you have the ability to opt into getting a blurred version of that. The benefit there being is that a blurred version, because of how image compression works, allows you to get a similar looking image, like the color and the general shapes are similar, at a fraction of the size, single digit percentage some of the time. And because it's so much smaller, even though you're loading two images at that point, the smaller blurry version and the full size, the pixels start to get painted faster. As a result, as a user, you feel as though the whole thing's moving much quicker, and it gets a much better, much richer user experience. It's something that is pretty new to the AMP team and something you can implement on your own web page if you're not using AMP. I highly suggest it. Next thing we're going to talk about is the idea of prefetch, preload, and pre-connect. These are all built-in browser features that are fairly new. And the idea here is that you have the ability to to give hints to the browser that I'm going to want this style sheet, I'm going to want this piece of JavaScript, an image, or just about any remote resource. You add this as a head tag, and it can do all sorts of internal background work that has to happen before that can occur. So this could include stuff like doing a SSL handshake. So if you're trying to connect to a resource over HTTPS, you can start off that TCP connection. It can actually start to download and parse those attributes before in the background in order so that they're more readily available when they are requested. And then it can just have stuff more ready more quickly. It can make a really drastic impact. I think some of the Chrome studies had over a 60% change in perceived speed on certain web pages if you correctly use preload and prefetch. Now the caveat to all that is, of course, that you can't preload and prefetch everything, or else you lose all benefits. You need to make sure that you're optimizing the things that are the most likely to be seen by the user, and they are most likely to be interacted with by the user. This is something that AMP can actually take care of for you if you opt into the tooling through AMP Toolbox, which I'll talk about briefly in a minute, or you can just opt into the AMP cache. The AMP caches that exist will automatically add all these performance benefits for you automatically. And not only that, but they'll also automatically add future ones as they're discovered. Since it's an evergreen library, you just kind of inherit all these performance benefits just by opting into them. It's a great option to do if you're not already doing it. Pre-connect, on the other hand, is similar but slightly different. So load is all about grabbing that stuff, parsing it, having it ready for the engine so it can just do that mem swap at the last second, make sure that it's immediately there on the device. Pre-connect is something that where you won't necessarily need to do it for every resource, but you would want to do it for remote attributes. So this would be this would give you the ability to pre-connect to external domains. So if let's say you're going to be downloading images from Imager or Reddit or some other third-party service, you can pre-connect to that domain by using the pre-connect header. That allows you to, again, initiate all those DNS requests, TCP handshakes, all those things that might take a couple hundred milliseconds the first time it happens. You can get ahead of the line, end up shaving off a number of points off of your ultimate LCP score. It's something that's really important to make sure that you're measuring and that you're optimizing already. Now, one of the things that the AMP really tries to do is give anyone that's interested a tool to take care of all these things for you. Most of the time, a lot of these tools end up being inside of the AMP toolbox. We have stuff like the AMP optimizer, lint tool. There's just about all the really interesting tools are going to end up right here. So if you're not already familiar with AMP Toolbox on GitHub, I would highly suggest you check it out. It's something that is incredibly valuable for all of your AMP development needs. Now, I am greatly appreciative for everyone here. I just want to, as a couple of parting words, make sure that in the world of Core Web Vitals, you need to make sure that you're looking at measuring everything. It's incredibly important because Core Web Vitals is all about real user data. All this information is actually coming from real users and their browsing experiences. And so you need to make sure that you're measuring all those experiences. You need to try and find, where are the outliers? Are they in international countries? Are they going to be on low-end devices? And start to understand where your weak points are inside of your performance stack. It really helps you, give you a lens. You can use a lot of the tooling that is provided by Google currently. It's coming to a number of third-party tools in the future, but stuff like PageSpeed Insights or the Search Console all have high-performance analytics data around Core Web Vitals, and I would highly suggest that you start investigating that. But again, even more importantly is that you measure every single person. I think a lot of times inside of AMP development, people can default to feeling as though they really only care about the origin, or the AMP takes care of everything for you. This is something that people have heard from the AMP team over time, but it's actually really no longer the case. The AMP cache is not the only place that people go and get AMP content. This can come to them from sites like a number of large social media sites only link to the origin version. You have people that might share stuff through one device to the other. As a result, point is, you need to make sure that you're optimizing both your origin and your cache versions. By default, if you're relying on the cache for all of your performance optimizations, anyone that's going to your origin is not going to have them. They're going to have a much worse score, going to have a much worse user experience. So something you want to make sure you avoid by using one of our automated tooling within the AMP toolbox. Now, again, I could talk all day about all this stuff, and unfortunately, I'm not able to, but make sure that you can reach out if you're confused about any of this, or if you want to know how to implement something, you want to know more about any of these topics, reach out either in this chat or on GitHub. It's available everywhere. We are a lot of friendly folks on the AMP team. We would love to have any feedback or any kind of information you want to have for us. And with that, I'd like to say thanks. And that's it.